This video is an explanation of the fourth free response problem. So in part A of this problem, you have a spring that's compressed at first, and then when you let it go, it jumps up to a height h above where it started, and you've put several different masses, so these things, on top of them. Okay, in part A, you want to find an expression that relates the height that it jumps up, to mass x, the amount that the spring was compressed initially, and the spring constant k. Okay, between these two pictures, so this is like the beginning and end, beginning, end, energy is going to be conserved. There's no heat or work here. So at the beginning we have only spring potential energy, US, and at the end we only have UG potential energy due to the fact that this mass has gone up a height h. Because we know we're looking at the maximum height, it doesn't have any kinetic energy at the top because it has to come to a rest at this top before it starts to fall back down. Likewise, at the beginning, there can't be kinetic energy because you are putting your hand down on the spring, compressing it, and it is not moving. Okay, plugging in equations to these two, we have US, which is 1/2 k delta x squared. Okay, and the amount the spring is compressed by is just x, so we can write 1/2 k x squared is equal to mgh. Okay, it wants an expression for h, so we solve for h, and h is equal to k x squared over 2 mg. In part B, it gives us a data table, and it asks, first of all, what quantities should be graphed so that the slope of best fit you'll be able to find k. Okay, since we know that h is equal to kx squared over 2mg, and we have a data table, so this is part B, we have a data table of mass and height. What we can do, these are our two variables, height and mass, and you notice that we can rewrite this equation as h is equal to k over 2g x squared times 1 over m. Okay, so if I graph h on my y-axis versus 1 over m, then I will get a straight line, and its slope will be kx squared over 2g. Okay, so the second variable you have to graph is 1 divided by m. Okay, if you use their data and go through the numbers, you get 50, 33.3, 25, 20, and at the very bottom you get 16.67. Although I kind of ran out of room, but you should have 16.67, which I'll write up here at the bottom. Okay, and this whole thing is in the units of 1 divided by kilograms. Okay, so in part C, it asks you to graph the points that will help you calculate your spring constant, your k. And what we decided before was we would graph h, and h is in meters, versus 1 divided by m, which is in kilograms -1, or 1 divided by kilograms. Okay, and we have to label our axes. We have 0 and the maximum height is about 0.5 meters, and 0, the maximum value for 1 over m was 50 inverse kilograms. And when you graph the data points, you end up with a straight line, or roughly a straight line, that looks something like this. Okay, and I'm going to draw my red line in there. Okay, for part D, so that was part C. For part D, what you need to do is calculate the line of best fit in order to find the spring constant. Okay, so in part D, I know that in order to find the spring constant, I'm going to use this equation. H is equal to 1 over m times kx squared over 2g. And once again, kx squared over 2g is our slope. So what I need to do is find the slope of this line. Since I don't have an exact number, I'm just going to eyeball sort of rise over run. The maximum rise was 0.5 and divided by 50 to get 0.01 for my slope. Okay, then what I can do is set 0.01 equals k x squared over 2g. Solving for k, I have 2g times 0.01 divided by x squared is equal to k. From the problem statement, I know that x is 0.02, and when I plug in 0.02 for x squared and 10 for g, I end up with a k value that is about 500 newtons per meter. In part E, it asks me to describe a procedure for measuring the height h in an experiment. There are lots of good ways to do that. Use a motion detector. Will give you pretty accurate data. You could just put your hand there. You could time how long it takes to hit the ground after it leaves. So time of flight, and calculate the height using kinematics. Any of these things are good. Okay, to go back and talk about points. So there are 10 points in total. Going back to part A, if you realized that you needed to use conservation of energy, give yourself 1 point. If you actually found this guy, h equals kx squared over 2mg, give yourself 1 more point. Okay, in part B, if you realized that you should use 1 over m, give yourself 1 point. And then if you successfully calculated these values for 1 over m, so 50, 33.3, 25, 20, and 16.67, give yourself 1 more point. In part C, if you graphed using the correct axes, give yourself 1 point. and you didn't, you labeled your axes and you put the dots in the right place. One more point. In part D, if you realized you had to calculate a slope and used rise over run, give yourself 1 point. And if you correctly used that to calculate K, give yourself a 2nd point. For part E, if you gave me a good answer that wasn't just eyeball it, give yourself, actually, sorry, 2 points. Okay, so a total of 10 points.